Hello everyone, welcome back to my YouTube channel. This is Charita from Sri Venkateshwara College of Engineering, Computer Science Department. In this video, I am going to talk about efficiency of an algorithm from the subject Design and Analysis of Algorithm. Now let's get into the topic. Before going to the efficiency of an algorithm, we should know the algorithm and the properties of algorithm. First, First, we'll see what is meant by algorithm. An algorithm is a set of very defined instructions to solve a particular problem. It takes a set of inputs and produces the desired output. For example, an algorithm to add two numbers. First step is take two numbers input and add two numbers using a plus operator, and this will display the results. And here, the properties of good algorithm, they are input and output should be defined precisely. Each step of in the algorithm should be clear and unambiguous. Algorithms should be most effective among many different ways to solve a problem. An algorithm shouldn't include computer code. Instead, the algorithm should be written in such a way that it can be used in different programmed languages. The properties of algorithm mainly contains input, output, defectiveness, finiteness, and effectiveness. Now we'll discuss about the efficiency of an algorithm. Algorithm efficiency is a property of the algorithm which relates to the amount of computational resources used by the algorithm. An algorithm must be analyzed to determine its resource usage, and the efficiency of an algorithm can be measured based on the usage of different resources. Algorithmic efficiency can be thought of as analogous to engineering productivity for a repeating or continuous process. For maximum efficiency, it is desired to minimize resource usage. However, different resources such as time and space complexity cannot be compared directly. So, which of two algorithm is considered to be a more efficient often depends on which measures of efficiency is considered most important. An algorithm which takes fewer resources and computes result in the minimum time for a problem that algorithm is known as efficient. The efficiency of the algorithm is measured based on the usage of different resources and minimum running time. The efficiency of the algorithm depends on its design, implementation, resources, and memory required by it for the computation. Since every algorithm uses computer resources to run, but to analyze an algorithm, execution time and internal memory are essential to consider. If an algorithm if an algorithm contains only linear function having no loops or recursions, the efficiency of the algorithm or the running time of that algorithm is calculated by the number of instructions it considered. Next is measure of resources usage. Measures are normally expressed as a function of the size of the input. The two most common measures are time and space. Time Time is defined as how long does the algorithm take to complete. Space is defined as how much working memory, that is typically RAM, is needed by the algorithm. This has two aspects: the amount of memory needed by the code, auxiliary space usage, and the amount of memory needed for the data on which the code operates. Next, now we'll discuss about the time complexity. The time complexity of the algorithm quantifies the amount of time taken by the algorithm to run as a function of the length of the input. Note that the time to run is a function of the length of the input and not the actual execution time of the machine on which the algorithm is running on. The validity algorithm takes a finite amount of time for execution. The time required by the algorithm to solve given problem is called time complexity of the algorithm. Time complexity is very useful measure in algorithm analysis. Next, different notations in time complexity. Different notations of the time complexity includes big O notation, little o notation, big omega notation, little omega notation, and big theta notation. These are the different notations in the time complexity. Next is space complexity. Problem solving using computer requires memory to hold temporary data or final result while the program is in execution. The amount of memory required by the algorithm to solve the given problem is called space complexity of the algorithm. The space complexity of the algorithm quantifies the amount of space taken by the algorithm to run as a function of the length of the input. Here the both time and space complexities are the efficiency of the algorithm. To estimate the memory requirements, we need to focus on two parts, that is, a fixed part and a variable part. A fixed part, it is independent of the input size. It includes memory for the instructions that has code, constants, variables, and etc. A variable part, it is dependent on the input size. It includes memory for recursion stack, reference variable, etc. There are up to four aspects of memory usage to consider. They are the amount of memory needed to hold the code for the algorithm, the amount of memory needed for the input data, the amount of memory needed for any output data, the amount of memory needed as working space during the calculation. These are the four aspects of the memory usage to consider. In this video, I have explained about the algorithm, the properties of the algorithm, efficiency of the algorithm, measure of resource usage, time complexity, different notations in time complexity, and space complexity, and the four aspects of the memory usage. And thank you for watching. Please do like, share, and subscribe to my YouTube channel. We'll meet in the next video. Thank you all.